number of ways that each event can happen to get your total outcomes. I'm going to give you some time with your pods to do numbers 1 through 3 before we get to permutations. So kind of read through the examples, brainstorm with your pods, like how many ways are there to do each outcome, how many outcomes are actually occurring in that particular scenario, and see if you can get me a number. Some of the numbers today are going to get large, and I'm going to teach you a new function in the calculator, so make sure you have a calculator. Okay, go for it and get me those answers. I'm going to take attendance real fast.
This is Cronky. Can I go to the nurse?
Oh yeah, you're feeling sick, like super sick right now?
I just have a headache and
Oh.
I'm ready to get some.
I was gonna be like, you need to run out of the room right now. You go.
So basically 26 Q. No, plus.
Or 156,976,000. I might do that second time. Yeah, you're right. Share my share my
So how'd you guys do it?
26 and 26. So there's 3 black and white, like 3 letter ones and 3 number ones. So 26 and 26.
3-letter ones.
Okay, I'm going to interrupt.
Double tap.
Most groups are at least to number 2 by now.
Yeah, for some reason.
So on my round around the room, I saw number 1, we're done like real fast, right? It's kind of like the warm-up example, Zach's outfit creation. Here we're creating a sandwich in the sandwich line. We can choose from 4 meats, 3 cheeses, 3 breads. How many sandwiches can we create? Just multiply all our options together and we've got 36. Now again, we have the same issue with the sandwiches that we would have with Zach's outfit. Do they look good? Do they taste good? I don't know. It doesn't, like maybe I won't pair a certain cheese with a certain meat, whatever. Maybe you're not eating meat, whatever that may be. But yeah, there are 36 outcomes. Now I could tweak this problem, right? Like have you ever gone to like one of the sandwich shops and you order extra or double meat? Sometimes that's an option. Or you have a sandwich that has more than 1 meat on it. So what if we change it so that your sandwich selection, you can choose from 2 meats, a cheese, and a bread? Then you just have to multiply by another 4 for the meats, right? Assuming that you could have double bologna or something if you wanted, right? Okay, so 36 is easy. Okay, then let's talk about the license plate. And if you want to jot down next to example 2 and example 3, these are very common, similar working problems. License plates, passwords, usernames, PIN codes, those types of questions often ask about okay, you have to create an 8-digit or an 8-character password. How many passwords are possible when we're thinking about security? Maybe there has to be a special character or something like that, so you can add in all those different numbers. This will be the one time I tell you how many letters and digits there are on a quiz or a test. I'm happy to answer questions about the deck of cards for you, but I would expect you to know there are 26 letters and 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Okay, so the license plate has 3 letters followed by 3 digits. What'd you guys do to get your answer? Cole is saying 26 times 26 times 26 times 10, 10, 10. And I saw some people, as I was moving around the room, they shortened it to 26 cubed and 10 cubed. Okay, that would be totally fine. So think about what Cole is doing there. He has actually, on this license plate, you know, when you think about like building your sandwich or building your outfit, we had 3 choices: shoes, shorts, shirt. Or we had meat, cheese, bread. Now we have on the license plate, letter, 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 digit, digit, digit. So we have 6 choices. And he's counting how many ways to pick the first letter, the second letter, the third letter. Well, the alphabet always has 26. How many ways to choose the digits? 10, 10, 10. Okay. That's a pretty big number, right? Can someone tell me that number? Okay, excellent. Okay, what changes for example 3? Did any groups get to example 3 and change anything? Izzy, what did your group change about example 3?
Instead of just doing like 26 cubed, I did 26 times 25 times 24 because you're like shortening the amount you can use because you can't repeat it.
Excellent. So your choice is reduced because repetition is no longer allowed. If I use an A for my first letter, I can't use A again, so I'm B through Z, which is 25. Okay, and the same thing happens with 10, 9, 8. Now, later in our notes, we're going to see this kind of work again, where we're like counting down, and we're going to adjust for like when we don't count down all the way. So we don't need to go 23, 22, 21 all the way down. It's just for those 3 letters because we're making those 3 choices. I could amend this question. Oh, that's a big number too, right? But less. What is it?
It's like 11,232,000.
Yeah. 11,232,000. Okay, now I can amend this question a lot of different ways, and that's why I'm saying like passwords, usernames, license plates, they all kind of work the same way. You got to know how many letters and digits there are. But I could say like, how many license plates are possible in this format that start with the letter N? Then what would change about your multiplication? The first number of ways to pick a letter is 1, because it has to be N, right? And then your second one would be 26 or 25, depending on if repetition was allowed, and so on and so on. Okay. A good question, similar to this too, that I've seen before, like in ACT questions. Okay. They use the fundamental counting principle, and a lot of times it might be something like this. Like, how many 3-digit even numbers between like 100 and 999. Okay, well, you really don't want to spend your time on the ACT listing out the even numbers. Okay, one way to do it would be to consider, like, you could figure like from 100 to 200, right? That would be one way to go about doing it. But you can also use the fundamental counting principle here. What has to be true about this ones digit if you're going to be an even number? Multiple of 2, which is how many of the digits?
It's literally like
2, 4, 6, 8, 0, right? Is what it could end in, so 5. And then this number in the tens could be anything, right? 0 through 9 will be okay. So there's 10. What about this spot? 1 to 9, because it has to be a 3-digit number. If you put a 0 in there, then it's a 2-digit number. So instead of using 10, we would use 9. So multiply those together, what will we get? 450? So there's just like some different ways that we could ask about things, and you might use a fundamental counting principle. Okay, let's talk about permutations. The definition for permutations, that might be a word that you haven't heard before, is called, it's an arrangement of items in a particular order. And the most important part about this definition for the permutation is the word order. So I'm also going to write down here, and this is going to mean more tomorrow when order doesn't matter, but I'll write it today and say order matters. An example of an arrangement of items in a particular order would be like my seating arrangement in the room. So you have been assigned a seat at a particular pod, and let's say I'm gone, so there's a substitute. It matters that you sit in the right spot so that this sub knows who you are. So your order matters. You just can't sit anywhere you like it, in the pod or anywhere in the room. Okay, so a seating arrangement would be an example of a permutation. Or let's say we're getting ready for our high school graduation. We're going to be walking into the gym, and we're going to be seated. Order matters when we're in there so that when we go up to get our diplomas, we're already in the alphabetical order or the order that they want us. So that would be an arrangement where order matters. My first example is the example of going to the movie theater. And these next two I'm going to move through kind of quickly because it's really getting us to a larger point down at the bottom of the first page of notes here. Suppose 5 people are going to the movies. What movie do you guys want to go see? What's that?
Oh my gosh. That
Cats.
so
That's
bad.
perfect.
It looks so
Yeah,
bad.
cats. Okay.
It's the movie.
Yeah, cats, definitely. Okay, we're gonna go see Cats. Okay, and you and like 4 friends, so there's 5 people. You buy your tickets, you go into the movie theater. Of course, it's like super packed because everybody wants to see the new Cats movie, right?
No.
And there's not a lot of seats left, but you do find 5 seats all right next to each other, and then already sitting in that row is the wonderful Miss Crocky, eating her popcorn, getting ready for the movie Cats. So of course, like all you and your friends are fighting over who gets to sit next to Miss Crocky, because why wouldn't you want to sit next to your math teacher at the movies, right? Okay, so you're fighting, but in the end, how many people get to sit next to me? One. And how many ways can you get that first person in there? 5. You've got you and 4 friends. So there's 5 of you, right? So there's 5 ways to get someone in the first seat in the row. And then let's say Austin wins. So Austin gets to sit next to me for Cats. Oh my gosh, it's going to be so exciting and so good. So Austin goes into the row. Then how many ways do we have to put the next person in the row? 4, 3, 2, until finally Caitlin's just hanging out, ready to sit down, right? Yeah. She goes in. Okay, so this is a 5 times 4 times 3 times 2 times 1. We're going to use up all of our options. I think if you type that into your calculator, it's going to be 120. Okay, so there's actually like 120 different ways that you can arrange 5 people in those 5 seats. It seems like a lot, but a lot of times you might just be switching like one person around, right? Okay, the next example is an arrangement of letters. So I chose a word on purpose that didn't have any repeating letters. Thanks, T-H-A-N-K-S. And imagine you just have like Scrabble tiles with those letters. How many letters do you have? 6 letters. And we're just gonna like randomly pull the Scrabble tiles and then like write the letters in the order that we pulled them. And we're just gonna make like 6-letter arrangements. They don't actually have to be words. Okay. So, how many letters do you have on your first pull to choose from? 6. But once we put the T out there, that's the first letter we pulled. How many do we have for the next? 5, 4, 3, 2, 1. To make the 6-letter arrangement, we're going to go all the way down to 1. So again, these aren't really like hard to think about. It's just kind of like presenting what's going to happen. So 6 times 5 times 4 times 3 times 2 times 1. We already did 5 times all that stuff is 120. Multiply it by 6, and I think you should get 720. So wow, now there's 720 ways to arrange 6 things. But the point here is it's very common in probability to have this kind of counting, where you start at a number and you go all the way down because you're going to use up all your options, right? So we have a new notation for that. It's called a factorial, and that should be like close to the bottom of the page. Okay. Have you ever heard of a factorial before? Oh, yes, you have. Okay. The factorial is the exclamation point. So you read that as 7 factorial. And it means 7 times 6 times 5 times 4 times 3 times 2 times 1. But I'm going to teach you where that is in your calculator. So first off, you would have to type in the 7. And then on my little calculators, it's usually like diagonal from the second button, just like on the next row down and over one. It looks like PRB for probability. If you click that, then you have some options. You should see an exclamation point you can scroll over to and grab. And then you grab it and you hit enter. If you're on my graphing calculators, you're going to type in your 7. You're going to hit the math button that's underneath your alpha. And you see at the top you have all those like menus, number, something, complex, whatever. There's a probability menu. So you scroll over to that and about 4 down you should see your factorial. Anybody else got a different calculator and they're finding their factorial? Let me know. So IC or NCR, which we'll use tomorrow. Your NCR we're going to use later. Oh, it's on the screen. I'm going to use 7 and then second. Anybody else having trouble finding theirs? So you'll hit this option button, and then you get all these things. And if you do more, there's a probability. Option more. Anybody else having trouble finding theirs? What is 7 factorial then? 5040, and you can fill in the rest. 4 factorial means 4 times 3 times 2 times 1. Which is 24. What's 8 factorial? 40,320. So you can type those in. Just make sure you did it. Did anybody work ahead and do 0 factorial? What is 0 factorial?
1.
Surprisingly 1.
It's like 0. Something is 0.
So that's kind of like a weird one, you know, like 1 factorial, yeah, we'd all agree is 1, but we don't usually like multiply it by 0, so like wouldn't that just be 0? The best way I can explain 0 factorial to you is like if you're thinking about it under like the examples that led us here, where I was like placing people in an arrangement, 5 people, 6 letters, whatever that may be. If you have 0 items, how many ways can you arrange them?
1.
One way you don't arrange 0 items. So it seems sort of like counterintuitive, but that is helpful to know sometimes that 0 factorial is actually 1. If you do some large factorials, like try like 70 factorial. You know, 70 times 69 times 68 times 67, so on and so on. Your calculator may give you an error, or it's might say like overflow. So it's just saying like your number is too big, like it's like way too big. So you can kind of play around with different factorials to see what they're equal
What's
to.
the meaning of this like E and then like a number? Like,
Oh, that's scientific notation.
oh,
Yeah, when your calculator says something like 2.5 E, oh, it would have like a whole bunch of digits, wouldn't it?
yeah.
I'll just make some up. If it says 2.5487, blah, 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 and then it says like E to the 45, that's really saying like 2.5 times 10 to the 45th. So you'd move your decimal 45 places. Whew. Did it right. Okay, so in example 6, how many ways would you be able to organize those shirts in your closet? 40,320. It's just 8 factorial. Once you put your favorite shirt in, then you got one less shirt to go. So from here on out, if you want to do something like what that factorial is talking about, if you want to multiply all the way down to 1, you can use the factorial in your work. Okay. All right, let's flip it over. Okay, sometimes you don't want to use up all your options, okay? So in some cases, it really isn't so bad, like this example with the 6 letters. Imagine we have those 6 Scrabble tiles. How many different 2-letter arrangements can you make? So like TH, HA, NK, KS, those types of things. Well, when you reach into the bag for your first letter, how many options do you have? 6, and then for the second letter, 5, and that would be it, right? So there's like 30 different ways to get 2-letter arrangements. Are you okay with that? That's way better than listing them out. TH, TA, TN, TK, TS, SK, you know, all the different things. So it's just counting them. We have a notation for that too. That kind of feels like the one, I think Izzy's group, where you started going 26, 25, 24 on the license plate and 10, 9, 8, where we want to count down, but we don't want to go all the way to 1 like the factorial will do. So we made a notation for that. So I think it says the notation for arranging 6 total items in only 2 spots, so 6 letters into 2 arrangements, or 2-letter arrangements, looks like this, and I'm going to write it over here so I can write it bigger. It's a capital P. I feel like I'm talking over people and that I'm yelling, and I find that really annoying. So if you can just hold your conversations, it'll help me. It's a capital P. It's a 6 on the left, like as a subscript, so it's like below the regular line of text, and then it's a 2 to the right. So it's the total that you can choose from on the left, and it's the number that you're choosing on the right. So we have 6 total letters to choose from in the word thanks, and we want to put them into 2-letter arrangements. So we can write this. It's called a permutation. Now, did anybody notice in their probability menus that there was something that looked like NPR? That's how you can calculate a permutation into your calculators. So if you want to try this, type your 6 in first, your total. And then you'll go to your probability menu, and you'll pull up the NPR options, and it'll bring in the NPR, and then you'll type 2 and hit enter. See if you can do that and get 30 for me. It's a permutation of 6 items, pick 2 at a time, and it equals 30. Anybody having trouble finding NPR, raise your hand. You okay? Okay? Yeah, either method would be fun. We probably have to do, so 2 to 6, second, and NPR, 2. You always have to do. I would accept either work for like a quiz or a test. You could do 6 times 5 because you're thinking about it like we did with the license plate problem. Or you could do a permutation of 6, pick 2 because you think that's faster. Okay, either of those is fine. Now, I think I also have a follow-up question. How many three-letter arrangements then can you make? So we could shorten that and do 6P3. We still have 6 letters in thanks, and we're making 3-letter arrangements. So we're only picking 3 of them, not all of them. We don't want to do 6 factorial anymore. What will that be, 120? Okay, so in the next box, I have like the formulas. Okay. So, okay, suppose you want to do a permutation of n items. N is already your total items. There's 2 ways for you to do it. If you're using all of the options, you can do n factorial, right? That was a permutation of 5 people in the row at the movie theater. Okay, we'll go all the way down to the last one. Or you can do a permutation of n pick n. There's n to choose from. We're going to use all of them, so let's pick that number. If you want to test that, do like a permutation of 5 pick 5 in the calculator, and it'll equal the same as 5 factorial, 120. If you don't want to use all of the items, so you have n items, but you're only taking r at a time, then you're going to use the notation NPR, a permutation of n items, pick r at a time. And I'm going to write the formula for that, so why it works. It's n factorial divided by n minus r factorial. So that's its formula. Now you have the benefit of using a calculator. So right now I'm not expecting you to memorize the formula. You can use the calculator. Later on, like in pre-calculus, you might use that formula to do some algebraic work. Okay, but for right now, we're okay with using the NPR. Okay, but let me show you that example from the word thanks. A permutation of 6 pick 2 at a time. In the formula, that would be 6 factorial over 6 minus 2 factorial, right? That's n and r. That would be 6 factorial over 4 factorial. And then isn't 6 factorial 6 times 5 times 4 times 3 times 2 times 1, which I'm going to write as 4 factorial. What happens to your 4 factorials? They cancel out. And didn't we say a permutation of 6 pick 2 was just 6 times 5? Yeah. So it's doing that work for you. It's canceling things out. If you do an n pick n, then n minus n will be n minus n, 0. So your denominator would be 0 factorial, and that would be trouble if it was equal to 0, because then it would be undefined, but we know that 0 factorial is equal to 1, so then it's just n factorial, so they're the same thing. Okay, I'm going to skip over the extra examples. If you want to fill in the blanks, you can, where you're just like doing, what is that, 7 pick 3, so you could do 7 times 6 times 5, and then type it into your calculator. I want you to think about example 9. There are 8 final contestants for Miss USA. How many ways or how many outcomes are there for Miss USA and the runner-up? Well, there's 8 contestants, but we really only care about 2 of them. And does order matter when you're finishing Miss USA? Yes, you want to be Miss USA. You want to be crowned at the end, right? So order matters is going to be a permutation of 8 people picked 2 at a time, which if you do in your calculator is 56. Is it okay if you thought about it? There's 8 ways for me to pick Miss USA and then 7 ways for me to pick the runner-up? Yep, same answer. There are 6 students running a race. And how many ways can they finish first, second, and third? Does order matter when you're running a race? Definitely. You want to finish at the top? So we're doing a permutation of the 6 students. That's our total. And we care about the top 3. So permutation 6, pick 3 at a time. That would be 6 times 5 is 30, 90. Am I correct? Oh, 120. Oh, times 4. 6 times 5 times 4. I skipped the 3. That'll be it. 120. Think about this. Say we got these 3 people coming in the top 3. It's a different outcome when Marin is first, Cole is second, Carly's third, versus Cole first, Carly second, Marin third, right? Those are different outcomes in the race, so order actually matters. What we're going to deal with tomorrow is, what if order doesn't matter? So what if it's not a race? What if it's just, picking the top 10% of the class, and they get to wear some special thing at graduation? It doesn't matter if you're the top 1 or 2, you just need to be in the top 10%. So we'll have to account for like this group of 3 being the same any way we write it. And that causes some difficulty for us. So tonight on your homework, pay attention to whether it's asking you like the question of how many ways something can happen. That's what we've been focused on in our examples. And these numbers can get really big, right? Like we had like 11 million something. And then if it asks you about a probability, remember probability is a ratio of favorable to total outcomes. So if you're answering a probability question, it still needs to be between 0 and 1. Okay? But now we can start using these counting methods to figure probabilities.